Good afternoon, all. Today I'm going to take class on hypothalamo pituitary axis. What is this hypothalamo pituitary axis? Right? This is think about this is brain, and the hypothalamus is located on the base of this brain. And to this hypothalamus, this adrenal, this pituitary glands are linked. You can see here, this is hypothalamus, and this is pituitary gland. They are linked through infundibulum. And when you see the hypothalamus, there are two areas. This one is optic chiasm, and this one is mammillary body. And we'll see this linkage from this is a neuroendocrine linkage. Why this hypothalamo pituitary axis is so important? Because it maintains homeostasis in our body. Anyone say what is homeostasis? Balance in our body, like hormonal balance, stress. If any external stress is there, for that balancing, this one is this axis is very important. When it comes to hypothalamus, it has two areas. One is optic chiasm, as I told, and when it comes to pituitary gland, it has anterior, means front, and posterior, back. Two will be there, and this first we'll see the posterior pituitary, and in this posterior pituitary, this will contain nerve endings of these neuronal bodies, which are located in hypothalamus. Okay, and this hypothalamus, this contains two types of neuronal bodies. One is supraoptic neuronal bodies and paraventricular cells. These are magnocellular because they are big in size. These neurons are big in size, and when it comes to supraoptic neurons and paraventricular neurons, they both either they can release oxytocin hormone or vasopressin. What are the functions of oxytocin? It acts in appetite behavior, lactation, material balance, social and sexual behavior, hormonal release. And what are the functions of vasopressin? It is also called antidiuretic hormone. It maintains fluid balance and blood pressure. And these anterior glands, pituitary gland, will contain all nerve terminals. It don't have any cells. And this posterior pituitary gland, this contains all endocrine cells. So it is also called as this anterior pituitary gland, also called as adenohypophysis, because it contains all cells. And posterior pituitary is also called as neurohypophysis, because it all contains neuronal endings. So this one is sensitive, so it is located in sphenoid bone, which is strong. It will protect the pituitary glands. And now this part is over. This anterior is over. Now comes to posterior. This is very important, because all these hormones, these endocrine cells will release all these hormones: adrenocorticotropic hormone, thyroid stimulating hormone, prolactin, follicle stimulating hormone, luteinizing hormone, and growth hormone. Now we can see here in the posterior pituitary, these nerves cannot release these hormones, cannot give these hormones. Okay, what happens is these nerve endings will end up in these capillaries connected to that nerve endings. So whatever the hormones released from posterior, that is oxytocin and vasopressin, they are released into these capillaries, and they will circulate in the systemic circulation. Okay, and when comes to this anterior pituitary, you can't see any nerve endings here. Then how come this nerves will stimulate this? I'll tell you. This in paraventricular cells, there will be smaller neurons also. This supraoptic nerves, there will be all magnocellular, all are big neurons. And in the paraventricular, there will be small neurons also. So these small neurons, they end up in median eminence. This is located here. So these neurons will end up here, and they will release these hormones into here. Also some venous circulation will be there. So they will release that hormones here. Those comes to this anterior pituitary, and here the actual hormones will release. All these hormones will release. From this, it goes into the circulation, systemic circulation. So I'll tell you which hormones are released from which neurons. So here these neurons, these small neurons which are present in these paraventricular cells, they will release corticotropin releasing hormone. For example, these corticotropin releasing hormone, this end up in median eminence. Sorry, I connected this. This end up in median eminence, and these median eminence will release what is the corticotropin releasing hormone? What comes from corticotropin releasing hormone? Yes, adrenocorticotropic hormone. So this will comes from one set of neurons. They will release these small neurons. One set of neurons, they will release corticotropin releasing hormone. This will release will come this later, and next set of neurons, they'll release thyroid releasing hormone. So these thyroid releasing hormones, it also end up in median eminence. It comes into circulation. It comes here, and this releases thyroid stimulating hormone. Next, we'll come to other set of neurons. They are present in arcuate nucleus. This arcuate nucleus is located here. This arcuate nucleus, it also contain two sets of neurons. One set of neuron, for example, this one set of neuron will release dopamine. This dopamine has negative feedback on prolactin. It inhibits prolactin, okay? And it has another, this arcuate nucleus will have another set of neurons which will release growth hormone releasing hormone and gonadotropin releasing hormone. This growth hormone is responsible for releasing hormone is responsible for release of follicle stimulating growth hormone, and gonadotropin releasing hormone is responsible for release of follicle stimulating hormone. And here these follicle stimulating hormone and luteinizing hormone, they combinedly called as gonadotropins. These are responsible for all reproduction, this egg release, everything, this estrogen, progesterone. I'll tell you later. So we'll come from so this one understood, no? Any doubts in this? And now we'll go here. This one we have three axes. One is adrenal axis, hypothalamo pituitary adrenal axis. One is thyroid axis. We'll come one by one. And the other one is gonadal axis. This adrenal axis, this will come into place when there is stress. This is very important for stress response. What is stress? What is stress? What is stress? Is that a situation? Condition? Situation, right?
Very uncomfortable situation.
Right?
Yeah.
It's wrong. It is stress is not a situation actually. It is a response to this any stressor, any external stimuli, which is not required for our body. If suddenly if you have No, that's fine. Anything like sound, huge sound. That response, that is a response. Stress is a response to any stimuli. And now we'll see here this we went somewhere. This adrenal axis we have for stress response. This come into place. Hypothalamo pituitary adrenal axis. You all know this one. Hypothalamus. What happens? This corticotropin releasing hormone released from these neurons. These hormones will be released in hypothalamus. They are responsible for release of adrenocorticotropic hormone, and this adrenocorticotropic hormone is released from anterior pituitary. And these what is the response? What happens if this adrenocorticotropic hormone released into blood, released into systemic circulation? What happens? It went to where is this adrenal gland located? In kidney, on the adenocortex of kidney. So from there this adrenocorticotropic hormone acts on that cortex, and it is responsible for the release of these all hormones, mineralocorticoids, glucocorticoids, androgens. What are all these things? These are all steroids. What are these mineralocorticoids will release aldosterone. What is the aldosterone? Increase. This is like a stress response. How it is response? It is a stress response, and you see when more stress is there, that time increase sodium reabsorption will happen. Because of that, more fluid is uptaken. So because of that, blood pressure will increase. So whenever you feel stress, the blood pressure will increase. Why blood pressure increases will decrease the stress response? How?
It's like a fight or flight mechanism. You need more glucose for every part of your body. That's
No, that one is different mechanism. Increased blood pressure also will decrease stress response, and also these glucocorticoids will act like that. Glucocorticoids, what they will do? They will undergo glucose metabolism. What happens if more glucose metabolism is there? More ATP is produced. So you'll get more energy to fight to that response. And next is androgens. They'll release this also. Then we'll go to thyroid axis. Hypothalamo pituitary thyroid axis. These ones, as you all know, these nuclei, they'll release thyroid releasing hormone. And this thyroid releasing hormone is responsible for the release of thyroid stimulating hormone. So what is the use of thyroid stimulating hormone? It is responsible for fetal development and metabolism. You know how important is metabolism in our body. And these thyroid hormones, some other class is there. They will explain all about that. And next is hypothalamo gonadal axis. This gonadal, what are gonadotropic hormones? As I told you, those are follicle stimulating hormone and luteinizing hormone. And here in this follicle stimulating hormone, this acts on, as I told, this all things. This follicle stimulating hormone will act on, it stimulates the follicles to mature. And this luteinizing hormone will, what it will do? It will release the egg from the matured follicle. And after that, during this stage only, this estrogen will also be released, and progesterone also will be released. And these progesterone and estrogen will act on implantation of that egg, and all those reproductive stages will happen. And no reproduction means menstruation will happen. All this estrogen has, and also we have to know there will be positive and negative feedback mechanism. Whenever these hormones are more in this bloodstream as this venal circulation, when these will they'll have receptors there. Here the receptors will be located. For each hormone there will be receptor. Whenever the hormones are more in this systemic circulation, there will be negative feedback going to that area wherever that hormones are released, so that they'll stop the release of that hormone. So estrogen will have positive feedback in release of this gonadotropin releasing hormone, and by the way, this progesterone will have negative feedback on the release of gonadotropin releasing hormone. Okay, and that's it. Any doubts are there?